In this video, I'm going to demonstrate some DSE problems that frequently appears in the DSE examination. Question 56. First, we mark down the position of the center. Then determine whether HK is positive or negative. Compared to O, H is on the left-hand side, so H should be negative. K is above O, so K should be positive. R is the radius of the circle, so R should be positive. After we determine whether HKR is positive or negative, we can check the statements one by one. Statement 1. The key point is to compare the distance from center to the x and y axis. K is a positive number, so the distance from center to the x-axis is equal to K. But for the distance between the center and the y-axis, h is a negative number, so the distance should be negative h. Compare the two distances. K is longer than negative h. After we move terms, we have h plus k greater than 0, so 1 is correct. Statement 2. Notice that r is a positive number and h is a negative number. Their difference must be positive. That means it is greater than 0, so 2 is correct. Statement 3. We can compare the radius r and k. Notice that k is longer than r. After we move terms, we have 0 greater than r minus k. Write it in another way. That is r minus k smaller than 0, so 3 is wrong. Only 1 and 2 are correct, so the answer is A. Question 60. Read the question carefully. It is the diameter of the circle passes through the point 6, negative 5. And the slope of the diameter is negative 4. Notice that every diameter must pass through the center. From the general form of the circle, we know that D is negative 8, A is positive K. We can find the center by the formula negative D over 2, negative E over 2. That is negative 8 over 2, negative K over 2. We have 4 negative K over 2. Now we have 2 points on the diameter, the center, and 6 negative 5. Therefore, we can use the slope negative 4 to set up an equation to find K. We have negative K minus negative 5 over 4 minus 6 equal negative 4. So negative K plus 5 equal 8. Negative 2 equal 3. So K equal negative 6. Therefore, the answer is A. Question 61. So now the straight line x minus y equal k cuts the circle at point A and B. We need to find the x-coordinates of the midpoint of AB. So here I want to explain how to find the x-coordinates of the midpoint of AB. Let A be x1, y1, B be x2, y2, and M be the midpoint. Using the midpoint formula, the coordinates are x1 plus x2 over 2, y1 plus y2 over 2. In order to find the half of x1 plus x2, we have the 3 steps approach. Step 1. Similar to finding the intersections of the straight line and the circle. When we find the x-coordinates of the intersection, we use the straight line, make y be the subject, and substitute into the equation of the circle. So step 2. After we simplify the equation, we can form the equation in the unknown x. Step 3. Do not solve the equation to find x1 and x2. Instead, we can find x1 plus x2 directly. Because it is the sum of roots of the quadratic equation, we can use negative b over a to find the answer. Then we can find the x-coordinates of the midpoint by doing 1/2 times sum of the roots. Now I use this MC as an example. From 1, the equation of the straight line. X minus y equal k. We have x minus k equal y. Then we put y equal x minus k into the equation of the circle. So we have x squared plus x minus k squared plus 2x minus 4 times x minus k minus 1 equals 0. Next, we expand all the brackets. We have x squared plus x squared minus 2kx plus k squared plus 2x minus 4x plus 4k minus 1 equals 0. We have 2x squared minus 2kx minus 2x plus k squared minus 4k minus 1 equals 0. Then we group the coefficients of x by taking out minus and x. Lastly, we use the formula 1/2 times sum of roots to find the answer. From the quadratic equation, we know a is 2, b is negative 2k plus 2. The sum of roots is negative b over a. That is negative 2k plus 2 over 2. For the numerator, we take out 2, so we have 2k plus 1, and the denominator is 4. Simplify the fraction, we have k plus 1 over 2. So the answer is C. If the question asks you to find the y-coordinates of the midpoint of AB, that is half of y1 plus y2, we can also do the same approach. But this time we sub x into the equation of the circle. But this time we form a quadratic equation in y. Only when the quadratic equation is in unknown y, we can use the sum of roots to find y1 plus y2, and then multiply it by 1 over 2. We can get the y-coordinates of the midpoint of AB.